Hello everyone! Today we are working on 3-4 arithmetic sequences. Don't forget to list your name, the date, and the period at the top of your paper. So we have here in the bottom and in our box vocabulary words sequence, term of the sequence, arithmetic sequence, and common difference. Now for the word sequence, we can define this as an ordered list of numbers that often forms a pattern. So sequence is an ordered list Now our second vocabulary, term of the sequence. And this just means that each number is a term of the sequence. Now we also have arithmetic sequence. And this is the difference between any 2 points I mean to say any 2 consecutive terms. And it is a constant difference. So for this, the arithmetic sequence, it just means that between 2 consecutive terms, we either add or subtract. And then we get the next term. Now we also have common difference as our last vocabulary word, and is defined as the difference between any 2 consecutive terms. And now we have here an example 1. So it's the ordered list 26, 39, 52, 65, and 78, an arithmetic sequence. So let's first find the common difference between all of these terms of the sequence. So these parts, so we have our first term here, our second, third, fourth, and fifth. And remember, these are our term of the sequence. And to find the common difference, we need to see how much we had to add or subtract. But since it looks like we are going up in the scale, we are looking for the number that we added for each term. So from 26 to 39, let's work backwards. Let's say 39 minus 26. And that would be 9 minus 6 is 3, and 3 minus 2 is, oh, nope, not 1, not 2 I mean, but it is 1. So from 26 we added 13 to get 39. And then let's see from 52 to 39. Well, you can borrow a tens from the 5 and then get 1. Oh my goodness. It's supposed to be 12. 12 minus 9 is 3. 4 minus 3 is 1. So once again, we added by 13 from 39 to 52. And now from 65, from 52 to 65, we're going to subtract. 5 minus 2 is 3. 6 minus 5 is 1. So once again, we added by 13 from 52 to 65, the third and the fourth term of the sequence. And from 78, from 65 to 78, once again we get 13. So now we know that the common difference between all of these points is 13. And since we have a common difference between any two of the consecutive terms, this means that it is an arithmetic sequence. So yes, it is. So now we move on to part B of example 1. How are sequences related to functions? Well, we can think of a sequence as a function where the domain is the natural numbers and the range is the terms of the sequence. So then, since we are working with n, with terms, we can call them n terms. So then let n be the term number in the sequence. And as for a of n, let a of n be the value of the nth term of the sequence. So then we just will take the example from part A and look at our nth term 1. So our first term, we had 26. And then for our second term, we had 39. And then etc. Now we move on to part C of our example 1. How do you represent sequences using subscript notation? Subscript notations are the ones we have been using with our point labels. So the x1, we had the y1, and then we also had x2 and y2. So they're the small numbers that goes in the bottom left of our variable or number. And when we're using it with arithmetic sequence, we can put in a2 equals 39. And this just means that it is the second term is 39. So we can either use function or subscript notation to represent sequences. Now let's do a try it problem. And it states that an a of n is the value of the nth term of the sequence 26, 39, 52, 65, and 78. Is the domain of the function continuous or discrete? And explain. So then, the domain of this problem, of this sequence, is discrete, and it represents the number of terms, and it only includes natural numbers. So the domain is a discrete function it represents the number of terms, and it only includes the natural numbers. So 26, 39, 52, 65, and 78, those are natural numbers. Now let's look at the recursive definition. So recursive in mathematics, it means to repeat a process over and over again, using the output of each step as the next input. A recursive formula relates each term of the sequence to the previous term. It is composed of an initial value and a rule for generating the sequence. So then the recursive formula for an arithmetic sequence is A1, which is the first term of sequence. And then we have AN equals AN minus 1 plus D, where AN is the nth term of the sequence. And A minus 1 is the previous term of the sequence. And D is our common difference. So a recursive formula describes the pattern of a sequence and can be used to find the next term in the sequence. Now let's work on example 2. What is a recursive formula for the height above the ground of the nth step of the pyramid shown? Now it gives us that each step is a 26 centimeter tall. So then from there we can conclude that the first term can be 26. And so if we use that in our formula, which is AN equals AN minus 1 plus 26. So for part B, let's use that recursive formula we have found, which is AN equals AN minus 1 plus 26, to find the height above the ground of the third step, meaning we're looking for the third term. So then let's put in A3 equals A3 minus 1 plus 26. So we had plug in 3 in our n variable. And then if we solve for that, we'll have a3 minus 1 is 2 plus 26. Now a2 was, if we solve for it, if we add by 26, $52. So then our second term is 52 plus 26. And then 52 plus 26 is 878. Now we have our measure for the third step of the pyramid. Let's do another triad problem. And it states that to write a recursive formula to represent the total height of the nth stair above the ground if the height of each stair is 18 centimeters. So then, instead of working with 26, like in the pyramid problem, we're working with 18 centimeters. And if we put that into our formula, which was a minus n minus 1 plus d, we plug in the 18 in the common difference. And now we would have an equals an minus 1 plus 18. And that is the recursive formula for this problem.